All right, you guys, so let's talk about test number 2. Which of the following are functions? This should have been the first part of the notes we started for this unit. So remember, each input must have only one output, right? So let's take a look at this. If we have, let's see, none of these inputs are the same, so that means this one should be a function, right? Because you don't have to worry about if any of the same inputs have this different outputs. What else? For B, we have, here we have 2 and 2. It's the same input, and they have different, oops, I didn't know that was going to do that. They have different outputs. I guess the only highlight color I get is yellow. They have different outputs, so that one is not a function. Okay, so is a function is not a function. Okay, for these down here, you can just use your vertical line test, right? So if you draw your vertical line through the function, it should only touch once because there should only be one output per input. So this one, because of vertical line test, yes. And this one, see how it's touching twice? So vertical line test, not a function. Why does the vertical line test tell us whether the graph of a relation represents a function? So we just talked about this. It can tell us if there is, let's just one output per input. Okay. Find the domain and the range of the function represented in graphs. So I wish, let's see, maybe I can find another pen color. Oh yeah, perfect. So let's do our domain as blue, and let's do our range as pink. And the reason I'm talking about that is our domain is going to be where this function exists on the x-axis, and our range is going to be where this function exists for our y values. And a lot of you are still getting confused about this. So I want you to really think about what this seems like. When you were thinking about domain, I want you to ask yourself, what is the smallest x value? That's a weird color. I'm going to go back to black. So for domain, I want you to think. And you always have to start with the smallest number. So what is the smallest x value? Okay. And then what is the largest x value? And then, are there any breaks? Well, I'm going to erase this, so write it down. Are there any breaks in value? Okay, so I'm going to erase this, but I hope you wrote it down. Pause it and write it down. Oh no! Because that's what we're going to ask ourselves. So here for the domain, and then for the range, you're going to say the same thing, those same 3 things, except it's going to be for the y value. So for the domain for the first one, whoops, sorry about that. So for the domain for the first one, what is the smallest x value? So our line comes like this. What is the smallest x value, which means what is the smallest blue, gosh darn it, what is the smallest blue number here, right? So, okay, I gotta see if I can turn my computer over. Ha! Word. Oh, no, that's not going to work. Sorry, guys. Okay, so the smallest x value seems to be -3. And the largest x value, I'm going to have to erase my colors here because we needed to see this point. The largest x value is 0. So our domain, and this isn't, gosh, hold on, I'm going to pause so I can see if I can fix my computer. So our domain is, because that's an open circle and the smallest number, I don't know what button I'm pushing that brings that up. That's the problem. So we're going to put in negative, oh my god. So we're going to put -3, comma, to the largest, which is 0, but it can be 0, so it's going to be like that. Okay, the domain for the second one is going to be, it looks like it goes on to infinity over here. So -infinity, 2, and it looks like we can always go along this way. +infinity. And the domain of the last one, now don't forget you've got to put your smallest value first, so -infinity to 3. But it can be 3 there. Okay, so let's go back and do our range. So our range, we're only looking at the x-axis right there. Or the y-axis, I'm sorry, range is y. So this first one is going to go, it looks like -4. And looks like it could probably be -4. And then up to 0. Okay, and that's going to be our range for this little function. This next one, it looks like it's going to be our smallest value. It's going to go down forever. So -infinity, but it's only going to go up to +3. Okay, whoops. And this one over here, it's not going to go below, it looks like 2 right here. So that's going to be the smallest y value, but it's going to go up forever. It's going to go up forever very slowly, but it will go up forever. So we have 2 to +infinity. Find the domain and range of this function. So when you're finding the domain and range of a rational function or something that's written as a fraction, you first have to think about when does this not work for the domain, and that's when the denominator is 0, right? You can't have a fraction whose denominator is 0. So our two zeros, our x1 is going to be +4 and our x2 is going to be -5. Both of those things are going to make this function cease to exist right there, but it can be every other number. So to write that in interval notation, you have from -infinity to the smaller number, -5, union, there's going to be 3 of these, union -5 to +4, union 4 to +infinity. And the range for this, we're going to have to look at, if you graph it, I'll pause this and graph it for you guys, but we're going to have to look at our horizontal asymptote to figure out where the range is not going to be. So as you can see from the graph of this function, there doesn't seem to be a horizontal asymptote, or it's a slant asymptote, but our y value, because of this middle line here, right? Our y value looks like it can be from -infinity to +infinity. So our range, so if that was our domain, our range is going to be +infinity. So find the domain of this function. Well, we know that underneath here, 2x, God, we know that it's going to drive me nuts. I have to figure this out. We know that 2x plus 5 must be greater than or equal to 0. Okay, so underneath there has to be greater than or equal to 0. So 2x has to be greater than or equal to negative 5. So x needs to be greater than or equal to negative 5 halves. All right, so we can write the domain. If the x has to be bigger or equal to that, then that's the smallest number. So our domain is x can be negative 5 halves to positive infinity. And our range, when you graph this, you're going to be able to see where it starts. I think it's just going to be at 0, but we can go ahead and graph this. Let's see, how do I get out of here? On Desmos. Or you can graph it on your graphing calculator when you get your graphing calculator. What this is going to look like is the square root. Oh, it looks like we're just going to have to type that in. So SQRT, the square root of 2x plus 5. 2x plus 5. So you can see from this one that it looks like it goes from 0. Right, we have a point right there, which is 0, 0. And it goes on for infinity. So that's going to be the range for this one. The range is going to be a hard 0 to positive infinity. All right, you guys, and we will start piecewise functions next.